Alright, so I think I'm recording. I've been having difficulty with these recordings. Sometimes it's not recording the sound, and sometimes it just right in the middle stops recording, so I don't really know what's going on. Alright, so we're looking at these polynomial functions, and we are trying to uh, work on new methods for finding x-intercepts. Previously, our only skill to do that really was either factoring or the quadratic formula for quadratic functions, and then for higher order polynomials, factor by grouping. But now, with this rational zero theorem and the fact that the remainder theorem and the factor theorem, that we can create a list of possible rational zeros, which are the x-intercepts, and use synthetic division, that remainder theorem, to find factors and to help us factor these higher orders. So before we jump in and start doing some of these higher order, fourth degree, fifth degree polynomials, we're working with just second degree polynomials, kind of that idea, walk before you run, because we can do this two ways. We can use just our old methods of x method and factoring or quadratic formula, and we can find the x-intercepts. We don't need this rational zero theorem to do it, but we want to build confidence in this rational zero theorem, so that's why we're using it, and then we're confirming, we're verifying that our answer is correct using methods that we know how to do. So this notation, a sub naught, that's the notation for the constant term when this is written in standard form. Make sure that your polynomial is in standard form, and also make sure that you look for a greatest common factor before you start in and looking in these the factors of the constant term and the leading coefficient. So 2 is a prime number, and the factors of 2 are just simply plus or minus 1 and plus or minus 2. And the leading coefficient here, 5, and it's a prime number, so we just have plus or minus 1 and plus or minus 5. So the constant term is the possible numerators that I use for my list, and the leading coefficient is the possible denominators. So if I just use 1 as a denominator, then I have 1 divided by 1. I have 2 divided by 1. And now when I use 5, I've got 1 divided by 5 and 2 divided by 5. Now we're not saying that these are the x-intercepts, we're just saying if this polynomial function has x-intercepts, and if those x-intercepts are rational numbers, it'll be in this list. So let's go through and use synthetic division. We could just plug in the values to see what produces an output of 0, but I'm going to use synthetic division just for the practice. So if I use 1, again, make sure this is in standard form, so I've got 5, negative 11, and 2. And I do not, 1 is not an x-intercept, because I'm expecting a remainder of 0 if this were a 0 of the function, if this were an x-intercept, if this were a root to this function. Let's try negative 1. And again, I do not get a 0, so I can scratch off 1 from my list. Let's move on to 2. Remember, the first number is always brought straight down in that synthetic division. Then if you're below the line, you get multiplied by the number in the box. And we have found a 0. We have found an x-intercept. So what that now allows us to do is to factor our original function. This f of x that's equal to 5x squared minus 11x plus 2 as one of its factors. Since 2 is an x-intercept, then in factor form x minus 2 x minus 2 is a factor, and now from the answer in my synthetic division, that 5 minus 1 is 5x minus 1. Multiply those together and you would get the 5x squared minus 11x plus 2. And of course, if you set this equal to 0, that's how you find the x-intercepts given an equation. You let y equal 0 and then solve, and these are the x-intercepts. Now you already had the skills to get these answers. You already had the skills to come in and say, if this function were 5x squared minus 11x plus 2, that you can solve this equation. Now, most of you just factor with the possibilities, just looking at it in your head, and of course the Algebra 1 team here to help students pass that ECA. Some students have difficulty with factoring, especially if the leading coefficient is some number different than 1. So what they showed them was a method that they referred to as an X method, that they draw an X over the middle term, and at the top of the X they take the first term times the last term, 10x squared, and then come up with two numbers that when multiplied together give you the 10x squared, but when added give you a negative 11x. So a negative 10x and a negative 1x seem to do the trick. So then, if you remember, well, you may not, again, it's doubtful that when you learn to multiply binomials, you probably just did them in your head, or some type of scratch work, or some type of arrows that maybe they said FOIL. For some students, to help them with the distributive property, they teach them to multiply binomials in the form of a table. So since you're learning to multiply in the form of a table, if we're factoring, if we're dividing, we also use that table. We just work from the inside and work outwards. See, normally when you're multiplying, you start on the outside and then fill in by multiplication the inside of the table. So with this table, they take the first term and the last term of the expression, and then what you found in your x goes along the other diagonal, and these diagonals are interchangeable. You can switch. I could have put the negative 10x up here. So then I look horizontally and I look and see what they have in common, and what they have in common here, since this diagonal is both negative and that's positive, I'm going to say that a negative 2 here, because vertically here, call that a negative 1. And so now when I check it, negative 2 times the negative 1 is positive 2. When I look and see what do these have in common, well, they have an x in common. And here, what do these have in common? Well, 5 divides both number, and x is also a factor of each of those. So we can see that we have x minus 2 and 5x minus 1 from this table. And then of course you get the same values that we did just a second ago for the x-intercepts. This is kind of a nice method, an organized method, this x method, to factor things, especially because even when there's the pre-AP students, if that number 5 was not a prime, if that number 5 was a composite number with a lot of different factors, a lot of different combinations, a number, like 12 or 24 or 36, where you've got a lot of combinations, the people that do it in their head might accidentally skip over the right combination that they need. Here, there was only one way to get the 5x squared, that's 1x times 5x. But if that number were 36x squared, are you doing 1 and 36? Are you doing 2 and 18, or 9 and 4, or 6 and 6? I mean, there's a lot of different, 3 and 12. There's a lot of different possible combinations if you're just trying to do it in your head, and this kind of gives you a systematic way to attempt it. All right, so I hope that helps.